So today we're going to go through the indirect proof part of it. So let's go through the steps that you need to do for each one. So when I have you do an indirect proof, it's not a 2-column proof anymore. When it says indirect, it's going to be 3 steps. And I'll say, show the 3 steps that you need to prove this indirectly. The first one, state the negation of what you want to prove. We practiced those the other day. I think that'll be easy. Step 2 is kind of the one that's a little bit harder, especially if it's a geometric one. The algebraic ones are pretty straightforward, so I think you'll kind of like those because they are a lot easier. And then the third one is a little tougher too because it's kind of like a little paragraph style, or at least a few sentences to conclude that the assumption you made is false and the one they made must be true. Okay, so we're going to go through that right now. Okay, so here is the problem, and you'll have to write the given and the proof statement in there. Remember that if it is an if-then statement, the if part is the given, the then part is the prove. So just in case you've forgotten that, because it's been a little while since we've done these. So the given is triangle ABC is scalene. We want to prove that A, B, and C all have different measures because, of course, that's what the definition of scalene is. So step 1 is to state the opposite of the given. Okay, so we're going to assume, how do you do the opposite of ABC is scalene? Just is not, so you don't have to change that many words. Assume triangle ABC is not scalene. Remember, with these, it's easier to just keep it simple than to say, okay, if it's not scalene, then maybe it's equilateral, or maybe it is isosceles. If you do that, you are picking one in particular, and we're going to do everything that is not scalene. So you have to kind of put them all in one category. So if you keep it simple, then you can show any of those. If you don't, then you're going to be missing parts that might be true. Okay, so first step we generally all get because that's the easiest one. The second one is a little bit tougher because we have to do some stuff, and then it's like if you've never seen one, what do you do? So I'm going to draw a triangle and label the vertices. Okay, so make a triangle, label the vertices. It doesn't matter if it's different than mine. Make sure you put the A, B, and C in there. So if it isn't scalene, we want to assume something about that particular triangle that we've made. Remember that if it's not scalene, it could be isosceles, it could be equilateral. We either have no sides the same, 2 sides the same, or all sides the same. Okay, so there's actually 2 options that you could do. With this one, you could assume that it's equilateral if you wanted, but we're going to do 2. Okay, so if it isn't scalene, let's say oops. I'm going to add to this. So in order to actually do what we're going to do next, we have to actually add to it. So assume triangle ABC is not scalene and that there are 2 angles that are the same. So we're just picking whatever 2 angles we want. If you did yours, you could do B and C are the same, you could do A and C are the same, you could do all of them the same. It kind of depends on where you're going to go with it. So since A and B are the same, what kind of triangle is it? 2 angles are the same. What is it? Isosceles, right? So we had some isosceles triangle theorems back a while back, right? We had one where if you have 2 sides the same, the opposite angles of those 2 sides are the same. We also had one that said if you have 2 angles the same, the sides opposite those are also the same. That's the one that we're going to use. So That one happened to be the converse of the isosceles triangle theorem. So we said A and B are the same, which means that this side and that side are the same. So AC is congruent to BC. But at the beginning, in the given, didn't they say that the triangle was scalene? How many sides do we have the same? We have 2 sides. That's a contradiction. So you're going to say something that you know is going to be false. Everybody that does this, you are never going to be right because that's not the style of this proof. So you assume something that eventually you use reasons and things to prove that it's false. So then you can turn around and say theirs must have been true. So let me fix these words that just moved. Okay, so by the converse of the isosceles triangle theorem, AC is congruent to BC, which contradicts the fact that triangle ABC is given, and that's at the beginning. So whatever you're going to say in here, you're going to prove that what you said is false and what they said is true. So now the last, step 3, is sometimes a little paragraph, sometimes it's a sentence or 2. So it doesn't have to be real, like, rigid, but don't just say, like, you know, a little tiny, you know, it has to be a sentence like, I should say. So at the end, here's what we're going to say. And I'll write it first and then say it. Okay, so here's what I said. The assumption that 2 angles of triangle ABC are congruent must be false, and the original angle A, angle B, and angle C are all different must be true. You could say that the original triangle ABC is scalene must be true. You can say this in so many different ways, but you have to say that yours was false and theirs is now true. So you have to do something that contradicts. You can't have a scalene triangle and an isosceles triangle at the same time. Or if you chose to do an equilateral triangle on this one, you can't have a scalene and equilateral triangle at the same time. So if you chose equilateral, which is a way that you could have done this one, you would have to use equilateral theorems, which you would find in your theorems. So you have to back it up. You can't just say mine is false without any backup. Okay, so that's what makes these a little bit harder when they're geometry related. If they're algebra related, which is the one we're going to do next, there's a straightforward method, and I think you'll do okay on those. Okay, so let's do one of those as well. So here we go. So we are given an algebraic expression, and it says what the answer is not. They want us to prove that y does not equal 6. So different style, but we still are going to do the 3 steps. And I'm going to go back to this one for a second. When we said I'm going to change this first one again. What you need to do is to do step 1, and I was just looking, I didn't do that right. You need to do the opposite of the proof statement, so we should not have that scaling part in there. I'm just going to go with this. So here it said prove that A, B, and C have all different measures. We chose to say that 2 are the same. Okay, so nothing about scaling there. It's only about the proof statement. And then at the end, you show that it isn't scaling, or it has to be scaling. So I'm going to go opposite of proof statement. Goes here. Sorry about that. So we're going to do the same thing on this next one, where it is algebraic. Okay, Jordan, get off your phone, please. So 7 times x plus y equals 70, and x does not equal 4 is the given. The proof statement is y is not equal to 6. So if we're going to do the opposite of this in step 1, we're going to say assume y does equal 6. So sometimes it's just a simple little statement that there isn't much to do. The step 2 is going to be just actually solving this equation. So if we assume that y does equal 6, what we're going to do is substitute 6 into the original equation and see what happens. Okay, so I'm going to start with this by substitution. 7 times x plus 6 equals 70. I'm not going to worry about the x doesn't equal 4 part yet. So if we do that, we would distribute the 7, or could we also divide by 7 if we wanted to get rid of it right away? So I'm going to actually divide by 7 because it's going to be faster that way. Those cancel, and you get x plus 6 equals, and it's 7, not 70, 10. And then to solve for x, solve for x, we subtract 6 from both sides. And we get x equals 4. Now, what was the number we weren't supposed to get? 4. That's the contradiction right there. Okay, so in step 2, we found that x was equal to 4. Okay, so this contradicts the fact that in the given, they had x couldn't equal 4, and now we just have to kind of reword it. So whatever you plug into this thing is going to be false every single time. Don't assume that you can find something that works because it won't. That's not the main thing here. You have to show that it's false, and that's what you're going to do every time. So I keep mine a little bit shorter. The book is really wordy in their last paragraph. We've kind of shown it already, so I'm just going to say the assumption that y is equal to 6 is false, and the original must be true. And that's basically that y couldn't equal 6. The book, if you want to look at that one, is a little bit wordier. So let's look at that one. Look at, maybe I just showed you this one. I don't think they do. Oh, here we go. It's a got it question. They say the temporary assumption that y equals 6 led to a contradiction, so we can conclude that y does not equal 6. I can't see any of you guys speaking like that, so don't just copy the book. Put it in your own words, and it's basically this. The assumption that we made is false. Theirs must be true. Keep it simple. You don't have to be wordy. It doesn't have to look like you're writing something that you wouldn't even say. keep it simple. Yep.
So could we say that for like every one assumption that we made is false?
Practically, yes. There's some that you have to get a little, like the geometry ones are a little bit harder because you have to say stuff. But for these, keep it simple. You know, keep it simple like that. The only thing that I will only give you half credit for is if you can't do step 2, but you know what step 3 is supposed to look like, you probably would get half credit there. But you do have to get step 2 right to get step 3 right. So I'll give you the fact that you know what this is supposed to look like, but you didn't get the points for step 2. So do everything you possibly can. You might get full credit, you might get half credit depending on, you know, what you're showing. But the algebra ones are definitely easier. I know that there's one like that on the test. There might be one geometry related one, kind of like the one we did. So I don't step really far out of the boundaries, and I could. I just want you to know kind of what they are and what they look like and what you have to do. They are tough because it's not like in our thinking. You know, we don't think like that normally, think the opposite of what is true. And that's kind of the style of this proof. So you guys will have a couple more to do. I want you to add it to the assignment that we did 2 days ago, the 5.5 from the book. And then I have a short worksheet that I want you to do for today as well.